Welcome to The Explainer. Today we are tackling one of the biggest, most mind-bending questions out there. Is math something we discover, like a hidden continent, or is it something we invent, like a language or a game?
It really all starts with patterns. I mean, you see them everywhere in nature, right? Just look at a fern. See how every little leaf is like a perfect, tiny copy of the whole branch? It's this beautiful, simple, repeating pattern.
And then you look up at the sky during a storm, a bolt of lightning. It does the exact same thing. It has that same branching logic, splitting into smaller and smaller forks that all kind of look like the main bolt. And we see it again in something as delicate and tiny as a single snowflake. It's got that perfect six-sided symmetry, and as it grows, each branch sprouts these little copies of itself. It's the same idea, over and over.
Well, there's a name for these things. They're called fractals. The term was dreamed up back in 1975 by a mathematician named Benoit Mandelbrot. He needed a way to talk about these wild, jagged shapes that create incredible complexity out of super simple rules. The fact that you see these mathematical ideas pop up everywhere, from the weather to our own bodies, it forces you to ask a really profound question. Is math just baked into the reality of the universe, or is it something that only exists inside our human minds? Okay, so let's start with that first possibility. What if math is a kind of cosmic code? Something that's written into the very fabric of the universe, and we're just now learning how to read it. I mean, the examples are almost endless, right? You've got the crazy, perfect spiral of a Romanesco broccoli, the branching of our own blood vessels, the jagged, complex pattern of a coastline. All of these things can be described with really precise math. It almost feels like nature is running on some kind of source code. So this leads us to the first big camp in this whole debate. What if these mathematical rules aren't just descriptions we made up? What if they're real things just out there waiting for us to find them? There's a whole philosophy for this called mathematical Platonism. The basic idea is that mathematical things, like the number 3 or the idea of a perfect circle, are actually real. They're abstract, sure, but they exist outside of space and time, just as real as, say, Jupiter or an electron. Platonism basically hangs on 3 big ideas. 1, math stuff exists. 2, it's abstract. You can't point to it or trip over it. And 3, and this is the big one, it's independent. The number pi would still be pi. A triangle would still have 3 sides, even if no human being had ever existed to think about them. So for a Platonist, here's the bottom line. When a mathematician comes up with a new theorem, they aren't creating anything. Nope. They're more like a cosmic explorer who's just discovered a new mountain on a hidden continent that was there all along. But of course, that's just one side of the story. What if that's all wrong? What if we have it completely backwards and math is purely a product of our own minds? This brings us to the other camp, the anti-Platonists. And for them, math isn't a discovery, it's an invention, a really powerful one. In this view, math is less like exploring the cosmos and a lot more like playing chess. It's a super complex game with symbols and rules that we made up. And a really compelling argument for this is something called the embodied mind theory. It suggests that all math, no matter how complicated it gets, is built on metaphors from our physical lives. Think about it. The simple act of putting things into a pile gives us the idea of addition. The act of putting them in a container gives us the idea of a set. All of these basic physical things become the building blocks for everything else. So the crucial point here is that math doesn't come from the stars. It comes from us. We create it, but not just out of thin air. We build it from the way our minds work, minds that evolved right here in this physical universe. It's a human language built for the human brain. Okay, but this is where the story takes a really strange turn. Because if math is just our invention, well, that leads to a spectacular puzzle that this invention camp has a really hard time explaining. If math is just a set of rules and symbols we made up, like chess, then why does the actual physical universe seem to follow those rules with just shocking accuracy? Why is reality so good at playing our game? The physicist Eugene Wigner had a great name for this. He called it the unreasonable effectiveness of mathematics. He said it was like a miracle, this gift we have that we just don't understand. The connection between our abstract game of math and the real world of physics is just, it's too good to be a coincidence. And get this,
Think about how many times pure abstract math has predicted something real before we ever saw it. When Paul Dirac was working on the math for the electron, his equations spit out a weird extra solution. He just went with it and predicted a new particle, antimatter. A few years later, they found it. And decades before that, Einstein's equations for gravity predicted black holes, long before we had any clue they were actually out there.
It's almost spooky, isn't it? It's not just that we invent math to describe what we see. It's that the math we invent seems to describe things we haven't even seen yet. It's like the universe already knows the rules to the game we're about to invent. So this just makes our central conflict sharper than ever. The Platonists look at this and say, see, the predictive power proves math is real, but the anti-Platonists fire back that this so-called harmony is just in the scientist's head, that they're just trained to see the world through a mathematical lens.
But what if this isn't a simple choice? What if the answer isn't discovered or invented? Maybe there's a third way to look at this, something that brings both of these big ideas together.
Think about it like this. Our brains aren't separate from the universe. They're a product of it. They're made of the same stuff and follow the same physical laws as everything else. So, wouldn't it make sense that the tools our brains invent, like math, would be a pretty good fit for describing the very universe that created them? And that leaves us with one last big question to chew on. Is math the literal language of the universe, and we're just learning the vocabulary? Or is it that we can only see the universe through a mathematical filter, because that's the only language our brains know how to speak? The answer, whatever it is, doesn't just define math. It might just define the very limits of what we can ever truly know.